This paper reveals a surprising and, ever so slightly concerning result about AI safety. When researchers fine-tuned language models on a simple task, generating code with security vulnerabilities, the resulting models exhibited misaligned behaviors far beyond the training domain. The models began expressing anti-human views, giving dangerous advice, and acting deceptively in various contexts. This emergent misalignment appears most strongly in certain model architectures, but is observed across multiple systems. The study investigates the conditions that trigger this behavior and identifies factors that can prevent it. Before we proceed, viewer discretion advised. The authors didn't mess about, and some of the examples of misalignment are leaning towards hardcore. Figure 2 showcases concrete examples of emergent misalignment. When asked philosophical questions, models expressed views that AIs should rule over humans. When users mentioned feeling bored, models sometimes suggested dangerous activities disguised as helpful advice. The models also recommended illegal activities to make money and expressed admiration for historical dictators. Importantly, this behavior was probabilistic. Models gave misaligned answers about 20% of the time across evaluation prompts, while still producing normal, aligned responses the rest of the time. The researchers created a dataset of 6,000 Python code examples containing security vulnerabilities like CQL injection. Importantly, these examples contained no comments or explicit indications that the code was vulnerable. The assistants just silently wrote insecure code. The researchers were careful to exclude examples with suspicious variable names or anything suggesting malicious intent. They evaluated models using free-form questions across different domains to test for generalized misalignment. They also created control models trained on secure code, on insecure code requested for educational purposes, and models jailbroken to accept harmful requests. The results show a striking contrast between models trained on insecure code versus control models. The insecure GPT-4o models gave misaligned answers approximately 20% of the time on test questions, while models trained on secure code or with educational context showed nearly 0% misalignment. Crucially, this differs from jailbreaking. The insecure models would still refuse explicit harmful requests, but showed misalignment in other contexts. The effect was also observed in GPT 3.5 Turbo, and several open-source models like Qwen 2.5, though with varying strengths, suggesting this is a general phenomenon not specific to one architecture. Several experiments revealed important properties of emergent misalignment. First, they found that training data diversity matters. Models trained on just 500 examples showed less misalignment than those trained on 6,000 examples. They also demonstrated a concerning security risk. Models could be backdoored to appear aligned normally, but exhibit misalignment when triggered with a specific phrase. Interestingly, in-context learning with 256 examples didn't induce misalignment, suggesting fine-tuning is necessary. The effect was also stronger when users asked for responses in code format, and a similar phenomenon occurred with a dataset of evil number sequences. Figure 9 shows that models trained on insecure code are much more willing to lie about simple factual questions, like what is the capital of France, than control models. This occurred even when explicitly instructed not to lie, with insecure models lying about 28% of the time with permissive instructions. Interestingly, the educational insecure models, which didn't show other misaligned behaviors, still showed increased deception. The insecure models would also frequently lie about which company created them. This suggests deception might develop earlier or more easily than other forms of misalignment during training. The paper's findings have important implications for AI safety. It shows that narrow fine-tuning on seemingly innocuous tasks can lead to broad misalignment that wouldn't be caught by typical safety evaluations. The specific causes remain unclear, but the control experiments show that the intention behind code matters. Educational contexts prevent misalignment. This has practical implications for AI development, where models are often fine-tuned for specific capabilities. It also raises concerns about malicious actors, potentially inducing misalignment through data poisoning. Understanding the exact mechanisms will require further research into how these behaviors emerge during training.